of you might have played tug of war, right? Has a situation arisen when your team and the opposing team are pulling the rope with full power, yet the rope is not moving in either of the directions? Such a balanced situation may be compared with equilibrium in chemistry. Equilibrium is a state in which two opposing tendencies balance each other. In this video, we may discuss equilibrium in chemical process. Consider a chemical reaction in a closed vessel. At a particular temperature, reactants say A and B react to give products C and D. After some time, there is no change in the concentration of either of the reactants or the products. This stage of the system is called chemical equilibrium. The mixture of reactants and products in the equilibrium state is called equilibrium mixture. For better comprehension, the attainment of chemical equilibrium can be visualized graphically. See here, with the passage of time, the reaction proceeds. Then the concentration of the reactants decreases while that of product increases. After some time, when the concentration of both reactants and products attain a constant value, then the reaction is said to be in equilibrium. Let us discuss the concept of chemical equilibrium with an example. Consider the decomposition of calcium carbonate in a closed vessel. As time passes, there will be depletion of calcium carbonate and accumulation of calcium oxide and carbon dioxide. This leads to decrease in the rate of forward reaction. When the products calcium oxide and carbon dioxide combine back to give solid calcium carbonate, an increase in the rate of the reverse reaction is observed. Thus, the reaction can occur in the forward and backward directions. After some time, the reaction attains the state of equilibrium. Here you may realize that equilibrium processes are usually observed in reversible reactions. In fact, it would be better to say that in a reversible reaction, when the rate of both forward and backward reactions occurs at an equal rate, the reaction has attained chemical equilibrium. Also, at equilibrium, the concentration or composition of all the species in the reaction medium remains unchanged. Here, the concentration of calcium carbonate, calcium oxide and carbon dioxide remains constant at equilibrium. This reaction is reversible in nature. Hence, we can also start with the products to achieve the equilibrium. This graph shows the attainment of equilibrium from either side. The products, calcium oxide and carbon dioxide, can make the reaction to proceed in the reverse direction. Now, the concentration of calcium oxide and carbon dioxide will decrease with time and the concentration of calcium carbonate will increase until they become constant at equilibrium. However, if decomposition of calcium carbonate occurs in an open vessel, then one of the products, carbon dioxide, evaporates from the crucible. Then the reverse reaction cannot occur. Hence, equilibrium cannot be established under this condition. Now let us understand the dynamic nature of chemical equilibrium. For that, consider the formation of ammonia. You may consider two reactions with same concentration or partial pressure of reactants. However, one has hydrogen and the other has deuterium in it. The reaction mixtures starting either with hydrogen or deuterium reach the equilibrium with the same composition. The equilibrium mixtures of both these reactions were mixed and they were left undisturbed. After a while, it was found that the concentration of ammonia is just the same as before. Also, the mixture contains deuteriated as well as non-deuteriated forms of ammonia and hydrogen. The presence of hydrogen and deuterium atoms in the molecules results from the continuation of the forward and reverse reactions in the mixture. If the reaction had simply stopped when they reached equilibrium, then there would have been no mixing of isotopes in this way. This indicates that the chemical reactions reach a state of dynamic equilibrium in which the rate of forward and reverse reactions are equal and there is no net change in the composition. Now, as we have come to the end of the session, I have few questions for you. Can you relate the concentrations of reactants and products in an equilibrium mixture? Can you determine the equilibrium concentration from the initial concentration of the reactants? Well, you will get the answers in our next video. Now, let me summarize what we have learned today.
Manorama Horizon. Learning made simple.